So last week we talked about arithmetic sequences, and we started talking about finding the sum of arithmetic series. So just in review, arithmetic sequence is just the numbers that follow a certain formula, I guess is how I probably want to say it, whereas a series is the expression formed by adding the terms of that arithmetic sequence. This week we are going to focus on finding the sum of finite arithmetic sequences. And remember, finite means it ends. So this is going to we're going to give you a certain part to start with and one to end with. And we're going to find out the addition, the sum of all those things in between them. We have a formula to do that, and we're going to discuss this formula and we're going to work with it. But S sub n equals n times a to the first, a sub 1 plus a sub n, all divided by 2. So my n is the last term we want to include. So if I say find the sum of 17 terms, that's going to be the 17. We're going to do the sum of 17 terms. So the n is the last term number. So that would be a 17. My a sub 1 is going to be the first sequence number. Sorry, this is not wanting to write very well for me today. And then a sub n, in this case, it's going to be the last sequence number. So again, my example was 17. This would be the sequence value of term 17. All right. With that being said, we're going to do this two different ways. We're going to look at sigma notation and find the sum of it using sigma notation. And then I'm also going to show you how to find the sums if I don't have sigma notation. Sigma notation, as a refresher, when I have this one, the I equals is my starting term, the number on top is my last term, and the number following is my sequence. So we're going to use that to help us be able to use the formula that we have above. So let's start with our first example. The sigma notation of I equals 1 to 20, and my sequence is 3i plus 7. So what this is telling me is that I want to find the sum of my terms 1 through 20 in the sequence of 3i plus 7. So that would be how that sequence was formed. Couple things I need to be able to use that formula that we had above. The first one is I want to know how many terms I'm going to put together, and I get that number from right here, that 20. All right. The second thing I'm going to want to know is what is the value of a sub 1. And in order to find a sub 1, I'm actually going to plug 1 in for my I and figure out what that value is. So that would be 3 times 1 plus 7 would be 10. And then I'm going to do the same thing to find the a sub n, which in this case is my last term of 20. So I want to find the value of the 20th term. So this would be 3 times 20 plus 7, which would end up being 67. All right. So that's the information I need for the summation. And now I'm going to plug all of that into the summation notation. So I'm going to do the sum of the first 20 terms of this sequence. And according to my formula, I'm going to take the number of terms times the first term, which was 10, plus the last term, which was 67, that 20th term, and I'm going to divide by 2. And then when you type all that in your calculator and work that out, you would find out that the sum of these first 20 terms would be 770. So you're going to want that calculator to help you with some of that. Okay, let's look at number 2. So our second one says I have the sigma notation of 1 to 10, and the sequence is 9i. So the first thing I know is that I'm going to find the sum of the first 10 terms. I get that again from my ending value. My a sub 1, I would put 1 in for my I, so 1 times 9. So my first value sequence number is 9. And then I have to find the last one I'm going to put together, which would be the 10th term, and that would be 9 times 10, which would be 90. And then, once I have that information, let's find the sum of those 10 terms. So I'm going to do the first 10 terms. So I would do 10 times the value of my first term plus the value of my 10th term, all divided by 2. And I work all that out, and my answer here would be 495. All right, so that's already, if it's in sigma notation, it's really a matter of understanding the sigma notation and being able to find some of those terms. So let's look at what if it's not in sigma notation. What if they are just giving me some sequences? What am I going to have to do? So we're going to follow the same steps, and I've put them off to the side here for you. The first one is I'm going to find the first term. So remember, that's where I'm going to somehow figure out what a sub 1 is, whether I plug it into the sequence or I just see it, like I'm going to in the next couple problems. The second thing I'm going to do is find the a sub n. So whatever that last term is, that's what we call our a sub n. And if you don't see it, you might have to plug it into your sequence that you're given. Or in just a minute, we're going to actually go back and use that formula we were given to find, that we used last week to find the value of a term. And that was a sub 1 plus n minus 1 times d. And we're not going to be writing any sequences. We're just going to use it to find some values today. And then the last thing we're going to do after we find those two pieces is we're actually going to use our formula, the summation of whatever term, the nth term, is going to be n times my first term plus my last term divided by 2. Okay, so with that being said, let's look at number 3. We're going to find the sum of the first 12 terms. So that tells me already my n is going to equal 12. And then the next thing we know we need is a sub 1, which in this case I don't even have to work for. That's my sequence 7, 12, 17, 22. My first term is 7. Now, I can find the 12th term in a lot of ways. I could continue the pattern and find that, or I can use my formula that we have off to the side, this one right here, a sub n equals a sub 1 plus n minus 1 times d. I'm going to use that. I'm going to figure out what it is. So my first term was 7, plus I have the 12th term minus 1, because I'm actually looking for a certain term. And I need to find my common difference here. So if I'm looking at this, 7 to 12 goes up by 5. 12 to 17 goes up by 5. Remember, this is arithmetic, so once I know I have the right number it's being added by, I can kind of quit. And then I would work this out, so this would be 7 plus 11 times 5, which would end up being 62. And now I have my 3 pieces of information, so let's find the sum of the 12th term, which would be 12 times 7 plus 62 divided by 2. Type the sum of the 12th term into my calculator there, and I should come up with this equaling 414. All right, so we have one more to look at. This time we're going to find the 34th term, so my n is going to equal 34. My sequence is 11.7, 10.8, 9.99. So my a sub 1 that I can find here is 11.7. That's my first term. But what I don't have is the 34th term. So I might have counted out to the 12th term. I'm probably not going to count out to the 34th term. So using my formula will help me out a lot. I'm going to use again, this one, a sub n equals a sub 1 plus n minus 1 times d. So I'm going to have 11.7 plus, this is the 34th term, minus 1. And here, if I'm looking at my difference, I'm going to notice I'm going down by negative 0.9. So I'm going to times that down by negative 0.9. Type all that into my calculator. And that would tell me my 34th term was actually negative 18. So now let's find the sum of that. So the sum of the first 34 terms would equal my first term of 11.7 plus my 34th term, which was negative 18, divided by 2. And I forgot to put my 34 up front, so hopefully you caught that. If not, let's fix it. I'm going to multiply by all of that. Multiply all that out. Simplify what's inside the parentheses first. Go from there, and you're going to end up with 504.9. All right, good luck with that.